Welcome back. In this video, I'll be explaining the sum of nth term of its GP. In the last video, I explained how you can find the geometric mean given a 3 consecutive sequence in a GP. So, and don't forget the geometric mean is the middle number in the 3 consecutive number. Let's say I have ABC as 3 consecutive terms. Then I said this your B is your geometric mean, so which is defined as the square root of product of A and C. So if that is cleared, so today we are going to cover a series, that is the sum of n term of a GP. Recall when I explained the sum of nth term of an arithmetic progression, I emphasized that series is the sum of a sequence. Recall that the general terms of a geometric sequence is AR squared, AR raised by 3 up to what? AR n minus 1. You understand now? This is a sequence. Indeed, it is a geometric sequence. So when we now say series is the sum of sequence. You understand now? So it means when you have A plus AR squared plus AR raised by 3 plus dot 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 plus AR n minus 2, you know before n minus 1, I can have n minus 2, then plus AR n minus 1. So the sum of this sequence, this GP, is known as what? Is known as series. It means let us denote the series as what? Xn. That's my what? That's my series, that is the sum of this GP. Okay, now let us now obtain a general formula for the sum of the nth term of GP. It is not difficult to do since we already know that series is the sum. Okay, let us assume that I multiply through by R, that is the common ratio. But before we go, let's say I call this equation 1, multiply equation 1 by R. So if you multiply equation 1 by R, then this is going to be R, that is the sum, is going to give you AR, right? AR squared plus AR raised by 3 is I'm multiplying each term by R, plus AR raised by 4 plus AR n minus 1. Do you know how I obtain n minus 1? Because if you multiply this by R again, that's R raised by minus 1. You understand? If you apply your laws of indices, so it will be minus 2 plus 1, which is, that's why I obtain minus 1. Then plus AR raised by n. You understand? Let us call this one equation 2. So, you know, I can subtract equation 1 from 2. Likewise, I can subtract equation 2 from 1. So, let us take it one by one. Let's say I say equation 1 minus 2. That is, you subtract this term from this term. That's going to give me what? Sn minus Rsn. So, I don't have, in terms of A here. Then I can have A here. But AR minus AR, that will be 0. AR squared minus AR squared, that will also be 0. So, and so on and so forth. Then what you are going to have left here, because this guy will also subtract this, that will be 0. Then I'm going to have what's left? Minus AR raised power n. Do you understand now? So what I did, you know, I have A here. So it is like you're having 0 because you don't have a terms in A here. So it's like you're having 0 since we don't have first term here. That's going to be A minus 0, which is A. Then AR minus AR square minus AR square, everything will give you 0. So from here, you can have that, you know, your xn is common. If you factor it out, I'm going to have 1 minus R is equal to A is also common here, 1 minus R raised power n. You understand now? So if you make your Sn to be the subject of the formula, which is the sum, then I'm going to have that A into 1 minus R raised by n divided by 1 minus R. So This is the formula you can use for the sum of a geometric sequence. So where your A is the first term and your R is the common ratio, your N is the number of term. So similarly, since we have two equations, before we subtracted 2 from 1, what if we subtract 1 from 2? That can also give us another formula. If we subtract 1 from 2, that is, we say this minus this. So then I'm going to have RSN minus SN. You understand now? So RSN minus SN. So, but here I don't have AR. It's just like this is 0. I can just say 0 minus A. That's going to give me minus A. AR minus AR, 0. AR square minus AR square, 0. Then what are you still going to have left here? Then plus AR raised per N. You also have 0 here. AR raised per N will give you what? Minus 0 will give you AR raised per N. Then you can even rewrite this guy as AR raised per N minus A. You understand? So if you rewrite this equation very well, then I'm going to have RSN minus XN is equal to AR raised by N minus A. So my SN is common. If you factor it out, this guy will give me R minus 1. Then your A is common. That's going to R raised by N minus 1. So from here, you can make your SN the subject of the formula by dividing both sides by R minus 1. That's going to give you A R raised by minus 1 divided by R minus 1. So this is another formula. This one, this is another one. So you can use any of the formula. You understand now? So either of them works, but you have to use either of them based on the value of R. So here, if your R is less than 1, that if your R is not up to 1, you can use this guy. So, but if your R is greater than 1, you can use this formula. So please, you have to take note of that. So yeah, your A is the first term. So your A is first term. Your R is the common ratio. And your N is what? Number of terms. So if that is clear, let me give you an example to back it up. Example, example. So let me just copy it here because of the time. So example, I have in a GP, that is your geometric progression, the seventh term. Don't forget, in a GP, what is the seventh term of a GP? Recall it is T7, and with what I've explained, that's going, you first of all write AR and you subtract 1 from this guy. That's AR raised by 6. Then I'm going to have AR raised by 6 is, what did I call is? Is something as equals to what? 16 times, that is 16 multiplied by third term. So what is your third term? So your third term is what? AR. What are you going to put in the index? Since it is the third term, that's AR. You subtract 1 from 3. That's squared. AR squared. You can just pause a little bit since this gives you an equation you can solve. So then you have AR raised by 6 is equal to 16 AR squared. You understand now? So if you divide both sides by AR squared, then I'm going to have AR raised by 6 divided by AR squared is equal to 16 AR squared divided by AR squared. So now A cancel A, then I have R raised power 4 left. How do you obtain R raised power? Did we obtain R raised power 4? That is, if you apply your laws of indices, same thing as R raised power 6 divided by R raised power 2, that's R raised power 6 minus 2. If you forgot it, please refer to my video on laws of indices. So then R also cancel R, A cancel A, R square cancel R square, and you have 16 left. So which implies that your R is what? Fourth root of 16. That is, what is such a number you are going to multiply by itself 4 times to give you 16. That is actually 2. So then we know that my A is 2 from here. So then since we know it is 2, then I think I can find the value of my what? I can find the value of my A from there. You understand? So I can find the value of my A from there. So now you can say put Or before we do that, let us continue with the question. So we know already now that my r is equal to 2. And the second question, the second expression says the sum of the second term. You know this like the first sentence. So the second one says, and the sum of the second term. What is your second term of GP? That is AR. Don't forget sum is what? Plus, and the system. The system is the same thing as AR raised power 5 is equal to 102. You understand now? So then from there it is simple because you know your R, which is equal to 2. And wherever you see R here, you substitute the value of 2. You can say put R is equal to 2. If you put R to be 2, then I'm going to have 2A. You understand how I obtained that? Plus A into 2 raised power 5 is equal to 102. You understand now? So it's equal to 102. Then I'm going to have 2A plus 32A. 2 raised power 5 is 32 times A is equal to 102. You understand now? So if that is cleared, then this is going to give me 34A is equal to 102. Then if you divide through by 34, then your A will now be 102 divided by 34. So A is equal to 102 divided by 34. So once you know that your A is equal to 102 divided by 34, so then I can divide by this. So you know how many 2 can go here? I think 2 here is 17 and 2 here is 51. So I think 1751 is equal to 3. So your A is equal to 3. Then you can conclude adequately that your A is equal to 3 and R is equal to 2. But that's not the question. So what are we asked to do? Go back to the question. The question asks to find the common ratio R, so which we've done. You understand now? So now the question continue. If the common ratio is positive, because that I gave you two formula for the sum. Your sum is what? It can be A into 1 minus R raised by N divided by 1 minus R if your R is what? Is less than 1. That if your R is negative. So but if R is positive, that's R raised by N minus 1 minus R minus 1. So then we ask to find S8 minus S4. S8 minus S4, that is the sum of the first 8 term minus sum of the what? First 4th term. You understand now? So that is your X8 minus X4. So then you write the formula here. Since the formula will be given that my R is positive, so then I'm going to have 1 A raised by Rn minus 1 divided by R minus 1. Then minus what? Write the formula here as well. Then we can substitute it later. Divided by R minus 1. You understand now? So don't forget, we know the value of our A to be what? Our A is 3 and R is 2. Then you have 3 into 2 raised power. Then your N, since it is the 8th term, that's going to be 8 minus 1 divided by 2 minus 1. Then again, that's 3 into R raised power. Our R is 2, right? This is going to be 2 raised power 4 now because I'm finding S4, that is the 4th term. Sum of the first 4 terms minus 1 divided by 2 minus 1. So if you simplify it further, then I'm going to have 3 into 2 raised by 8 is 256 minus 1. Then minus 3, that's 16 minus 1. You don't need to, because 2 minus 1 is 1. You can leave that as it is. So then if you simplify further, this is going to give me 3, 256, that's 255 minus 3 into 15. You understand? So if I were you, I can put 3, factor 3 out, and this is going to give me 255 minus 15. And 255 minus 15, that's 240. So which will give you 720. So therefore, S8 minus S4 will give me 720. You know, it is very simple. If that is clear, let me give you another example to back it up. Example. And this like a why question. So with this, I think you can just solve any question in your WAEC, being your JAMB or NECO. So if the second and fifth terms of a geometric progression are -6 and 48 respectively, the second term, what will be your second term? AR. Your fifth term, that's AR raised power what? AR raised power 4. They said they are -6 and what? And 48. Then we have to find the sum of the first four terms. That's not difficult to do. Call this equation 1 and equation 2. So then from here, if I say 2 divided by 1, you can say 1 divided by 2, you are going to arrive at the same answer. So then I'm going to have AR raised power 4 divided by AR is equal to 48 divided by -6. So this will cancel this. Then you have R raised power 3 left. If you use your law of indices, right? So then this is going to give you -8. Then your R is same thing as cube root of what? -8. That is what is the number you are going to multiply by itself 3 times to give you -8. That's nothing but -2. Then your R is equal to -2. So since I know that my R is equal to -2, then you can put R is equal to -2 in equation 1. If you put R to be -2 in equation 1, then you have AR is equal to -6. That's A into -2 -6, right? So then your A will now be -6 divided by -2, which is equal to 3. So then we know that our A is what? A is 3 and R is what? -2. So the next question now has to find the sum of the first four terms. Sum of the first four terms. Don't forget, you have to write the formula we can use to calculate the sum. So that's going to give me what? S4. But now I have my R to be negative. So you are going to use the second formula, which is A into 1 minus R raised by N divided by 1 minus R. So then if you substitute that, then your A, that's 3, 1 minus -2 raised by 4. Do you know how we obtain 4? Divided by 1 minus R. That's 1 minus -2. So then your S4 will now be equal to, so if you simplify further, that is 3 into 1 minus, this will give me 16, because if a negative number is raised to power even number, you are going to have positive, and 2 raised by 4 is 16. That's why I obtained that. So 1 minus, that's plus. So that's 1 plus 2. Then you have 3 into -15 into 3. So 3 will cancel 3. Then I have -15 as my result. Alternative method you can use is this. So since I know that my A is equal to 3 and my R is what? R is -2. Since we have to find the sum of the first four terms, then you don't need to stress yourself. You know it's a sequence. Indeed, it's a GP. Then and you know for your GP you have AR squared, AR raised by 3. Then you can just substitute. This will give me 3. This -6. Then this one will give me 3 into -2 squared. 3 into -2 raised by 3. Then that's 3 minus 6. 3 into 4. And 3 into what? -8. So recall that since we have to sum them together, the first four term, then I'm going to have 3 minus 6 plus 12 minus 24. So 3 minus 6 is -3. 12 minus 3, I think it is 9. 9 minus 24 will give me -15. Can you see it's very simple? It is not difficult to solve. So that's how you can apply the formula for the sum of a GP to find, perhaps your A, your R, as well as the sum of an nth term of GP. So if you understand, please don't forget to like, share, and subscribe. So till I see you in the next video. Thank you.